Installing multiple circuits through a single conduit in residential wiring is a violation of the National Electrical Code, specifically Article 300.15 and Article 352.20. Article 300.15 of the NEC states that conductors should not be installed in raceways in such a manner as to cause mechanical injury to the conductors or raceways. Article 352.20 of the NEC states that conductors of different systems, circuits, or voltages shall not occupy the same wireway, raceway, or cable. When all the circuits in a residential house are routed through a single piece of 2-inch PVC conduit, several potential issues arise that violate these articles. Firstly, overcrowding within the conduit increases the risk of physical damage to the conductors. Cramming multiple circuits into a single conduit leaves little room for the conductors to dissipate heat, potentially leading to overheating and premature insulation breakdown. This insulation degradation can lead to short circuits, ground faults, and ultimately, electrical fires. Secondly, the practice violates circuit separation requirements. According to the NEC, different systems, circuits, or voltages must be properly separated. Mixing multiple circuits in a single conduit without proper separation increases the potential for accidental contact between conductors. This can lead to short circuits, where electricity bypasses the intended load and flows through an unintended path of low resistance. Short circuits can generate extremely high currents, causing overheating, arcing, and potentially igniting nearby combustible materials. Furthermore, using a single conduit for multiple circuits can make it difficult to trace and identify circuits later on. This can complicate troubleshooting and maintenance activities, potentially increasing the risk of electrical shock or other hazards for electricians or homeowners working on the system. The correct method for installing multiple circuits in a residential house involves using separate conduits for each circuit or group of circuits. This ensures adequate separation between conductors, reduces the risk of physical damage, and simplifies troubleshooting. When installing multiple conduits, it is important to maintain appropriate spacing between them. The NEC specifies minimum spacing requirements to prevent inductive heating and ensure proper heat dissipation. Additionally, each conduit must comply with fill limits, which specify the maximum number of conductors that can be installed in a conduit of a given size. Fill limits are determined based on the conductor size, insulation type, and the conduit's internal diameter. Exceeding fill limits can lead to overheating and damage to the conductors and conduit. When pulling conductors through conduits, it is important to use appropriate lubrication to reduce friction and prevent damage to the insulation. Additionally, care should be taken to avoid kinking or twisting the conductors, as this can also damage the insulation. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is developed and maintained by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Its primary goal is to ensure the safety of people and property from electrical hazards. Adherence to the NEC is essential for all electrical installations, whether in residential, commercial, or industrial settings. Failure to comply with the NEC can result in fines, penalties, and legal liability. Moreover, it can significantly increase the risk of electrical fires, injuries, and property damage. When working on electrical installations, it is crucial to consult the latest edition of the NEC and to follow all applicable requirements. It is also advisable to seek the guidance of a qualified electrician or electrical inspector to ensure that the installation is safe and compliant. There are different types of conduits commonly used in electrical installations, each with its own advantages and disadvantages. PVC conduit, or polyvinyl chloride conduit, is a lightweight and cost-effective option that is commonly used in residential and commercial applications. It is resistant to corrosion and can be easily cut and joined using PVC fittings. However, PVC conduit is not as strong as metal conduit and may not be suitable for applications where it is exposed to physical damage. EMT conduit, or electrical metallic tubing conduit, is a thin-walled steel conduit that is commonly used in indoor applications. It is lightweight, easy to bend, and provides good protection for conductors. However, ENT conduit is not suitable for use in wet or corrosive environments unless it is properly coated or protected. Rigid metal conduit, or RMC, is a thick-walled steel conduit that provides excellent protection for conductors. It is suitable for use in both indoor and outdoor applications and can withstand significant physical abuse. However, RMC is heavier and more expensive than other types of conduit. Flexible metal conduit, or FMC, is a flexible conduit that is commonly used to connect equipment that is subject to vibration or movement. It is easy to install and provides good protection for conductors. However, FMC is not as strong as rigid metal conduit and may not be suitable for applications where it is exposed to physical damage. The choice of conduit type depends on the specific application and the environmental conditions. It is important to select the conduit that is suitable for the intended use and that complies with all applicable code requirements. In addition to the conduit itself, it is also important to use the correct fittings and accessories. Fittings are used to connect conduits to each other and to electrical boxes or equipment. Accessories include items such as conduit straps, bushings, and lock nuts. It is important to use fittings and accessories that are compatible with the type of conduit being used and that are listed for the intended application. When installing conduits, it is important to follow proper installation techniques. This includes ensuring that the conduit is properly supported, that all connections are tight, and that the conductors are properly pulled through the conduit. Improper installation can lead to problems such as water damage, electrical shorts, and safety hazards. Electrical boxes are used to enclose and protect electrical connections. They come in a variety of sizes and shapes and are made from metal or plastic. Electrical boxes must be properly grounded to prevent electrical shock hazards. When selecting an electrical box, it is important to choose one that is the correct size for the number of conductors and devices that will be installed in it. It is also important to choose a box that is suitable for the environment in which it will be installed. For example, in wet locations, weatherproof boxes must be used. Wiring devices, such as switches, receptacles, and lighting fixtures, are used to control and distribute electricity. They must be properly installed and grounded to prevent electrical shock hazards. When selecting wiring devices, it is important to choose ones that are rated for the voltage and current that they will be carrying. It is also important to choose devices that are suitable for the environment in which they will be installed. For example, in wet locations, weatherproof devices must be used. Grounding is an essential safety measure that helps to protect people from electrical shock hazards. Grounding provides a low resistance path for fault currents to flow back to the source, which causes the circuit breaker to trip and energize the circuit. All electrical equipment and wiring systems must be properly grounded in accordance with the NEC. There are two main types of grounding systems: equipment grounding and system grounding. Equipment grounding connects the non-current carrying metal parts of electrical equipment to ground. This helps to prevent electrical shock hazards in the event of a fault. System grounding connects the neutral conductor of the electrical system to ground. This helps to stabilize the voltage and reduce the risk of electrical shock hazards. Overcurrent protection is another essential safety measure that helps to protect electrical equipment and wiring from damage caused by excessive current flow. Overcurrent protection devices, such as circuit breakers and fuses, are designed to trip or blow when the current exceeds a safe level. This interrupts the flow of current and prevents damage to the equipment or wiring. Circuit breakers are automatic switches that trip when the current exceeds a safe level. They can be reset after they trip, which makes them reusable. Fuses are one-time devices that blow when the current exceeds a safe level. They must be replaced after they blow. The choice between circuit breakers and fuses depends on the specific application. Circuit breakers are generally preferred for applications where frequent overcurrent events are expected. Fuses are generally preferred for applications where high fault currents are possible. Arc fault circuit interrupters, or FSIs, are a type of circuit breaker that is designed to protect against arc faults. Arc faults are dangerous electrical conditions that can cause fires. ASIs detect arc faults and trip the circuit breaker to interrupt the flow of current. ASIs are required in many areas of the home, such as bedrooms, living rooms, and dining rooms. Ground fault circuit interrupters, or GFCIs, are a type of circuit breaker that is designed to protect against ground faults. Ground faults occur when electricity leaks from a circuit to ground. GFCIs detect ground faults and trip the circuit breaker to interrupt the flow of current. GFCIs are required in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor areas. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges. Voltage surges are sudden increases in voltage that can damage or destroy sensitive electronic equipment. SPD divert the surge current to ground, protecting the equipment from damage. SPD are available in a variety of forms, including whole-house surge protectors and point-of-view surge protectors. Whole-house surge protectors are installed at the main electrical panel and protect all of the equipment in the house. Point-of-view surge protectors are plugged into individual outlets and protect the equipment that is plugged into that outlet. Electrical safety is of paramount importance when working with electricity. Electricity can be dangerous and can cause serious injuries or death if not handled properly. Always follow safe work practices and take precautions to protect yourself from electrical shock hazards. Firstly, always turn off the power before working on any electrical equipment or wiring. Use a voltage tester to verify that the power is off before you begin working. Secondly, wear appropriate personal protective equipment, or PPE, such as safety glasses, rubber gloves, and insulated tools. Thirdly, never work on electrical equipment or wiring when you are wet or standing in water. Fourthly, inspect electrical equipment and wiring regularly for damage. Replace any damaged equipment or wiring immediately. Fifthly, never overload electrical circuits. Overloading circuits can cause overheating and fires. Sixthly, use extension cords safely. Never use damaged extension cords or extension cords that are not rated for the intended use. Seventhly, keep electrical equipment and wiring away from flammable materials. Eighthly, teach children about electrical safety. Ninthly, if you are not comfortable working with electricity, hire a qualified electrician. Tenthly, always follow the NEC and other applicable codes and standards. When working on electrical projects, it is important to obtain the necessary permits and inspections. Permits are required for most electrical work and ensure that the work is performed safely and in accordance with the NEC. Inspections are performed by qualified electrical inspectors to verify that the work meets the requirements of the NEC. Obtaining permits and inspections can help to ensure that your electrical projects are safe and compliant. The NEC is a complex and comprehensive document that covers a wide range of electrical topics. It is essential for electricians, electrical contractors, and electrical inspectors to have a thorough understanding of the NEC. Homeowners can also benefit from having a basic understanding of the NEC. There are many resources available to help people learn about the NEC, including books, websites, and training courses. The NFPA also offers certifications for electricians and electrical inspectors. Proper planning is crucial for successful electrical projects. Firstly, determine the scope of the project and the required materials. Secondly, obtain the necessary permits and inspections. Thirdly, develop a detailed plan of action. Fourthly, gather all of the necessary tools and equipment. Fifthly, follow safe work practices. Sixthly, test the installation thoroughly after completion. Proper planning can help to ensure that your electrical projects are completed safely, efficiently, and in accordance with the NEC. Troubleshooting electrical problems can be challenging, but there are a few basic steps that can be followed to help identify and resolve the issue. Firstly, identify the symptoms of the problem. Secondly, check the circuit breaker or fuse. Thirdly, test the wiring and connections. Fourthly, use a multimeter to measure voltage, current, and resistance. Fifthly, consult a wiring diagram. Sixthly, if you are unable to resolve the problem, hire a qualified electrician.